All right, so today we're going to look at economic growth, and I apologize for you not being able to see me. My newer equipment is failing me today, so I've reverted back to putting together these slides on my iPad. So unfortunately, I don't have the video to go with it. All right, so we're going to be looking at economic growth, and we've been looking at economic growth in the past couple of videos. So we're going to do a bit of a recap, looking at definitions that we've discussed before, and then we're going to take that calculation we did before for economic growth and add one step to it. So previously, we had real GDP, and we could calculate economic growth from there. What we're going to look at now is what if you don't have real GDP? How do you first convert nominal to real and then find economic growth from that? So let's just dive into some definitions here. All right. And let's probably write in a different color than red. I think probably our preference. So let's start with what is economic growth? So our definition of economic growth is what? It is the change in real GDP per capita. So if we have our real GDP per capita, then we can do our new minus old divided by old times 100. That gets us the change part. Okay. So we'll need to find the real GDP, we'll need to divide by the population, and then we can use our new minus old divided by old times 100. Well, let's break that economic growth definition down further, and let's look at GDP. So what is the definition of GDP? GDP is the total value of all final goods and services produced in an economy in a specific period of time. So that's typically a year. Okay. Now, why do we look at final goods and services? Because when we add up the amount that's produced in an economy, when we add up the value of a cake, let's say it's $20, there are components inside the cake, right? The flour, the eggs. If we also included the sale of the eggs and the flour, then we'd actually be double counting those eggs because they are both in the price of the cake and in the sale of the eggs themselves. So we exclude those intermediate goods by looking at the total value of all the final goods and services produced in an economy in a year. Okay, so where do we get this GDP number? Well, if we go back, wrong graph, to that circular flow diagram that we've looked at in the past, there are two parts of the circular flow diagram where we can get that GDP measurement. One, of course, it says GDP here. Okay. And what we mean by GDP there is that it's the expenditure approach to finding GDP. So let's write out expenditure approach. And we have a formula for the expenditure approach. What was that formula? Looking at who does the spending in an economy. So we have C, that's the households, plus businesses, that's the investment spending, plus G, that's government spending. What are we missing? The rest of the world. And because we're only looking at the goods and services produced in our economy, we have to remove the goods and services that are sold in our economy but that we didn't make, and that would be subtracting the imports. So we have the expenditure approach for finding GDP. What was the other approach? Keep clicking on the wrong slide. The other approach was national income. So we can measure the size of the economy based on the value of what we make in terms of the goods and services, but we can also look at the size of the economy based on what we pay to make those goods and services. So we're national income, that's our income approach. And what was the formula for our income approach? Wages, interest, rent, and profits. So we can use either approach to get our GDP. And when we get our GDP, we need to recognize, do we have nominal GDP or real GDP? In order to find economic growth, we want real GDP. So we need to distinguish between the two. What's the difference? And if we have nominal GDP, we need to convert it into real. So what is the difference between nominal GDP and real GDP? So nominal GDP is going to be in current prices, okay? Whereas real GDP is going to be in base year prices. The idea here is that we have taken out inflation by looking at a common year in terms of the prices. So we said we want to take nominal GDP and turn it into real GDP. Well, how do we do that? Well, we actually have a formula that includes both nominal GDP and real GDP, right? We've looked at this formula already. Nominal GDP divided by real GDP times 100. Do you remember what was that formula for? Well, that's the formula for the GDP deflator. So we can actually rearrange that formula to find real GDP. Because the right side divides by real GDP, we can simply multiply real GDP on both sides of our formula. That gets it over on the left and gets rid of it on the right. We now need to move the GDP deflator to the other side. Since it's multiplied on the left, we can divide by it on both sides, and we get nominal GDP divided by the GDP deflator times 100 equals real GDP. So what this means is that if we have nominal GDP and the GDP deflator, we can calculate real GDP divided by the population and then look at the change to get our economic growth. So that's exactly what we're going to do here. So let's start first by going to find our nominal GDP. All right, so to find nominal GDP, we can go to StatsCan for this data. If you're looking for the US data, you would go to Fred. And you can also find nominal GDP for Alberta on the Alberta dashboard. All right, so we're going to go to where it says real GDP by expenditure on this right here. And we know if we go all the way down, we can find more data on these tables. Now notice table 2, table 3, and table 4 say real GDP. For the purposes of this exercise, we want to calculate real GDP, which means we don't need real GDP to start with, we need nominal GDP. So we're not going to use table 2, 3, and 4. It's also important to note here that table 2, 3, and 4 are the expenditure approach. Table 1 says by income account, so that's the income approach. Now, to find GDP, it doesn't really matter which method you use, the expenditure approach or the income approach, you should end up with the same number. Here we want to focus on nominal GDP. So we're going to go into table 1. Now, when you go into the summary table, it just gives you the most recent data. So it's giving us first quarter 2021 and second quarter 2021. Well, we need to pick a range, a one-year range, for calculating our nominal GDP in those two periods, and then we can find economic growth over it. So we're actually going to go to the source data. So you can see down here it says source, and we're going to click and go to the original table. The benefit of going to the original table is then we can actually pick which dates we want to focus on. So here we have second quarter, and let's actually look at second quarter 2020 and second quarter 2019. So we'll apply that. Okay, and so we can see here at the very, very bottom, it says gross domestic product. And so we can pull the Q2 2020 number and the Q2 2019 number. So we want to have it 1 year apart, and you can pick any quarter you want to focus on. The other thing that's important to note here is that it says that our data is in millions. So you can see we're going to need to add 6 zeros to the numbers when we pull them off this table here. All right, so let's write these down. So we have Q2 2020, we have 2001596. So I'm just going to go back to our here and start a new page. Q2 2020, and that number for that nominal GDP was 20, and then you got to remember what it was, 2001596. 2001596, and we have to add our 6 zeros. So when we look at this number, the first comma tells us thousand, the second comma tells us million, the third tells us billion, and the last one tells us trillion. So you can see here our nominal GDP is 2 trillion. Now we're going to need Q2 of 2019, so let's go pull that number while we have it. And that's going to be this first column here, and that's 2308,236. 2308 and 236. Again, we have to add our 6 zeros. Okay. All right, so now we have nominal GDP. And remember, our formula was nominal GDP divided by the GDP deflator times 100. So we need to go find the GDP deflator. Well, one of the easiest places to find the GDP deflator that I've found is that if you go to trading economics, you can go in and we'll look at our country. So let's go find indicators by country, and we're looking here at Canada. And the information we're looking for, okay, the GDP deflator, is a measurement of prices. So it's under prices as opposed to GDP. So we go to the GDP deflator, and we're looking for data from that same period of time. So Q2 of 2019 and Q2 of 2020. All right, so here we have July 2020. So Q2 would be the number right before it, so 108.9. Okay, and we're also looking for Q2 2019, so just before July 2019 is 109.8. I'm going to open the right thing here. 109.8. I'll just double check that since 109.8. Okay, and 108.9. All right. And open the right file. There we go. All right, so now that we have our nominal GDP and our GDP deflator, we can actually find real GDP for our two periods of time. So let's find real GDP for Q2 2020, and we'll take our 2 trillion. Oops. 215960000. We're going to divide by 108.9. So the idea here is to take your 2 trillion GDP and reduce it by the inflation, so 8.9% since the base year, and then you're turning it into base year value, so that's why you're multiplying it times 100. So let's do that calculation. And we need to pull up a calculator here. Let's see if I got a calculator. All right, now I got to remember the number. 2001598. Just double check the, nope. 2001596. 596, and then we have our 6 zeros. Make sure they're there. Okay, and then we're going to divide that number by 108.9. Oops. Divide by 108.9, and we're going to multiply that times 100. Okay. Now, if like my calculator, you have this 10 to the 12, this is telling you how many additional points after that dot you have, so it's trying to simplify the number. If you look at the original number here, this 2 trillion, see that we have our 6 zeros, plus we have the 596, that's 3 more, that's 9. Then we have the 1, that's 10, and then 0 is 11, and 0 is 12. So if you had 2 trillion, trillion, then you would have 12 additional digits after that. So that's what this is telling you, this 1.838 times 10 to the 12, is that there's actually 12 additional digits after where they've put the dot. So what we have here is 1838, 1838, then I'm going to have to go back and forth, 1838012. 1, 2, 856. Okay, let's just double check that here. 838012856. Okay, now remember there were 12 decimal places, so if I'm going to write this out, that was 369, and we need 10, 11, 12. So what we have here is thousand, million, billion, trillion. So if we're turning this GDP from nominal of 2 trillion into real, it becomes 1.8 trillion. All right, let's do the same thing for our real GDP for Q2 in 2019. So in 2019, we had nominal GDP of 2 trillion. So already we can see that in the previous year, so pre-COVID versus middle of COVID, we have, well, I guess Q2 of 2019 is the beginning of COVID, right? So 2308, 236, 000, divide by 109.8. So we can look at early days of COVID versus middle of COVID. So nominal divided by GDP deflator times 100. So again, we're taking that 2.3 trillion. We're adjusting it down for the fact there's been 9.8% inflation since the base year. And we are making sure we convert it into the base year. So that's why it's times 100. So let's put that into our calculator. 2308, 236. 2308, 236. And then we have to add our zeros. Okay, and then we're going to divide by our GDP deflator, which was 109.8. Okay, and we got to multiply it times 100. So notice again we have times 10 to the 12, which should make sense for us. We are, again, still in the trillions. And now we have a number of 21022, so let's write this down. 21022, 185, 79. Let's just double check that. 2102, 218, 579. All right, and remember it's going to be 12 digits after the dot, and we have 369 here, so we need to add 3 more. So 1,000, million, billion, trillion. So notice the real GDP in 2019 was 2.1 trillion. So automatically we can see that the total amount of goods and services produced, that total value of final goods and services, seems to be going down. And that's kind of mirroring what we saw during COVID. If we are staying home, then less is being produced and less is being sold. Now we need to take into consideration the population. That's the last piece here, because remember, we are looking at the change in real GDP per capita. So we're going to need the per capita piece. All right, so let's go find some population numbers for Q2 2020 and Q2 2019. Let's go back to our stats can. And back to that main page. Everything really comes off that main page. And the top one here for key indicators is our population. Now, when we look at this page, we see at the bottom here, it doesn't have those multiple tables. That's because there's really only one table it's building from. So let's go to this source table that we see here listed on the right. And we can see here the populations by province and countrywide. And again, it's showing the most recent data. So we're seeing 2021. Well, we need Q2 from 2020 and Q2 from 2019. So let's go Q2 2020 and Q2 2019 and apply. All right, and right now we're focusing on Canada, but you can explore other provinces. So let's look at Q2 for 2020 was 38,056,000. Notice when we look at the bottom where it says how to cite, it doesn't say there's any extra zeros we need to include. So we have 38 million people in Canada. So let's write that down. And what was that last number, 56? Okay, and let's also pull Q2 2019. Okay, so let's go in. Q2 2019, that's going to be our first column, 37,422,946. 37,422, and we go back, 946. All right, so we have our real GDP. We want to turn it into real GDP per capita. Okay, so we're going to take for our Q2 2020, we're going to take our 1,838,012,856,00, and we're going to divide by the population of that same time period, which was 38,000,056. Okay. Let's put that into our calculator. It's a lot of numbers to remember, so bear with me. Clear. 1838. 1,838,012,856. 012,856, and our 3 zeros. Divide by our population, and our population is 38 and 56. 38,000,056. Okay, so what we see here, that the amount produced per person in Canada for the second quarter of 2020 was 48,368 and 69 cents. 48,368. 368. And we can take the last two decimals if we want, or we could, because everything else has been in full dollar amounts, you can round to the full dollar as well. You don't have to have those two extra decimal points, 69. Okay. We can include them here if you want. All right, let's do the same thing for second quarter of 2019. We have our 2,102,218,579,00. Divide by our population at the time, slightly lower, 37,422,946. 946. Okay, let's plug that into our calculator. 2,102,218. 2,102,218. 579. And 3 zeros divided by, okay, let's go back, 37,422. And the last three were 946. Okay, and so here we have 56,174. And 59 cents. So notice that in 2020, real GDP was less, so we were producing less. our population was higher, so we're spreading less across the number of people, and so that can have a big impact in your GDP per capita. So let's now look at economic growth. To calculate economic growth, it's going to be new minus old divided by old. And I apologize, I'm actually going to squeeze this on the same page just so we can see all the other numbers. So to make it stand out, I'm going to just make it a different color. All right. So we're going to do, new minus old divided by old times 100 gives us our economic growth. All right, so the new number here, come on, go away, display. The new number here is actually the 48, 368 and 69 cents. The old number is 56, 174 and 59 cents. Divided by the old, 56, 174.59. And we multiply it times 100 so we can get our growth in percentage. All right, so let's put that into our calculator. Okay, 48,368.69. 48,368.69 minus 56,174.59. 56,174.59. I'm just going to double check that. Okay. So we'll hit equals. We've subtracted that. So we've gotten the difference between the real GDPs per capita, but now we need to divide by the old. And the old was 56,174.59. And it didn't do that because it's not doing order of operations correctly. That's where your brackets are needed, okay, in your calculation. Or if your calculator is different than this, just do the subtraction first, get the value, then divide. All right, what do we get? So here we have a number. We want to multiply it times, just let me get my equals done. All right, when we're all done, times 100. Okay. So we took new minus old divided by old times 100. And what we get is a negative 13.90 if we're doing two decimals. So our economy contracted by almost 14% between the second quarter of 2019 and the second quarter of 2020. So that's a big decline, okay, a big contraction. And that level of contraction, just to give you kind of context, the Great Recession in 2008, 2009, we've been talking about, economies saw kind of around a 10% contraction over that 2-year period of time. Some countries not so much, maybe 6 or so, others a little heavier, 15. So this is a considerable contraction, higher than we see in most recessions in a very short period of time. But because we know that it is because of medical or health measures, public health measures, likely it's very short-lived, in which case when things open back up, then all of that production resumes and that consumption resumes as well. People are buying and people are producing. So while it is quite a drastic reduction, it's not necessarily depression territory because of the small period of time we expect it to happen in. But you'll have to explore more current data to see if this contraction continues. Remember, to be in a recession, this contraction needs to occur for 2 quarters or 6 months. Okay, and that's why we can say that we have a COVID recession here. If we are talking about continual decline for 2 years, then we officially are in a depression. Now, we've been calculating economic growth. What we want to talk about this week is how do we get sustainable economic growth versus short-term economic growth. When we've been looking so far at whether the economy is contracting or expanding, we've been looking at leakages and injections. So first go back to our circular flow diagram and remember leakages are where money doesn't go directly from households to businesses to buy goods. It takes a detour. So we put money into savings and it goes into the financial market to banks. When we pay net taxes to the government, it's taking a detour. When our money goes out to other countries and not to our businesses producing our goods, it's taking a detour. So savings, net taxes, imports are all leakages. And then injections are where money is coming into the business and came from some other way besides households. So remember, businesses can buy from businesses, the government buys, and so do people in other countries. So these are the injections. So in the short term, we can look at leakages versus injections to determine if the economy is growing. And we talked before that when the leakages are more than the injections, your economy is shrinking. The air is going out of your balloon. If your injections are more than your leakages, your economy is growing. But these are short-term, temporary fluctuations in the economy. Okay, so when we change investment spending, government spending, savings, net taxes, they can be just short-term, temporary growth or contraction. What we want to look at this week as we dive into economic growth is how do you get sustainable long-term growth?